Alright, in this video I want to talk to you about how to find the equation of a tangent line at a given point in a function. So we've already talked about what the slope of a tangent line is, or how to find that. We proved it. It was called the definition of a derivative. And so I just wrote it up here just so we've got it for reference. Slope of a tangent line at some point P, which is on the function f, so point P is at a comma f of a, is the number m, which is m for slope. So the limit as h approaches 0 of f of a plus h minus f of a over h, okay? And again, I think I already mentioned that is really important. So in these examples here, and we might do 2 short videos instead of 1 longer video. So let's just do, but anyway, let's get started. We're going to do 2 things in each example. Step 1 is we are going to find, or step A, I guess, find the slope of the tangent at x equals a. And then part B of each one, we are going to find the equation of the tangent line. All right, and if I remember, this is also at x equals a. If I remember, we will also look at the graph as well, just to verify. So let's take our first example here. For some reason, x squared is a function we will analyze quite frequently because it is just interesting enough that it's useful, but also simple enough that we all kind of know, hopefully, what it looks like in our minds. So we want to find the equation of the tangent line of y equals x squared in the function y equals x squared at x equals 2. All right, so just a quick sketch. Here's x squared, more or less. We're looking at x equals 2. And so right here, we want to know what the equation of that tangent line is right there. Well, we know how to find the slope of a tangent line, or at least we're about to know how. It's using this limit right here. How might we use that limit? Well, let me show you. So we have, for part A, the limit as h approaches 0 of f of a plus h. So what does that mean? Well, a is the point that we're analyzing, the x value that we're analyzing. So that's 2, right? So we want the limit as h approaches 0 of f of a plus h, so 2 plus h, minus f of a. Okay, well that's minus f of 2, all divided by h. Okay? What we're hoping here is that this will end up being a number. And so you should ask yourself, well, okay, what is f of 2 plus h? Well, we know what f is, and you know what? Shame on me. I should have just used function notation here. We know that this is f of x. So f of x equals x squared. So I'm going to write this. The limit as h approaches 0 of f of 2 plus h. That means in place of x, I'm going to put 2 plus h. So it'll look like this. 2 plus h squared minus f of 2. Well, that is just 2 squared. Right? F of 2, if this is what f of x is, it's just 2 squared divided by h. All right. Now, the fun part. We are going to use algebra to simplify. All right. So here we go. Limit as h approaches 0. All right. We're going to keep the limit notation, by the way. So 2 plus h squared. That's going to be 4 plus 4h plus h squared minus 4, all divided by h. By the way, you try direct substitution with 0, it's not going to work. We're going to divide by 0. So what we're hoping is that something will simplify out of the top, that we'll be able to simplify the entire fraction and evaluate the limit. So this ends up being limit as h approaches 0. I have 4 minus 4, so that's 0. And I have 4h plus h squared over h. So I'm going to write that, 4h plus h squared over h. And there's an h in each term up here, so I'm going to factor that h out in front. So the limit as h approaches 0 of h times, let's see, we'll be left with 4 plus h here, divided by h. H over h simplifies to 1 over 1. And so I get this. The limit as h approaches 0 of 4 plus 0. Or sorry, excuse me, of 4 plus h. All right, now I try direct substitution, and I can plug in 0. And so I get the limit is actually equal to 4 plus 0, which is just 4. Okay? So there's a lot of work there, but remember, that is going to be our slope, right? I need two things to write the equation of a tangent line, or the equation of any line. I need a point and the slope. I have that because remember, we are going to be using point-slope form of a line. Y equals m times x minus x1 plus y1. So I'm going to plug in the slope and the point. The slope is 4. We just figured that out. And then I'll be left with, and then in place of x sub 1, I'm going to put 2. And then y1, well, that's just going to be 2 squared because that's the y-coordinate of this point. So that would be 4. And I'll be left with this. Y equals 4x minus 8 plus 4. Y equals 4x minus 4. All right, so there's this is part B, part B. So there's the equation of the tangent line through the point 2, 4 on the curve x squared. Let's double check. And so our equation of the tangent line was y equals 4x minus 4. And so there you can see pretty clearly that there's the point 2, 4. The line is the tangent line. We can zoom in if you want, but anyway, that is the equation of the tangent line, and that's how you do it. Now, the biggest problems that get presented here or that show up is in the algebra. So you can see how much algebra there was to complete this problem, and that will usually be the stuff that takes up the most amount of time, is doing the algebraic manipulation to get down to the limit. But otherwise, that's all there is to it. Find the slope, and then find the equation of the line.